friends, I am your Abram, meeting you after a long period of time. In this session, we are going to discuss about quadratic equations. So, what is meant by quadratic equation? So, before going to that question, let us make another question, which is, what is meant by a quadratic polynomial? Let us discuss about the definition of quadratic polynomial. So what is a quadratic polynomial? Quadratic polynomial is nothing but it has degree 2 in a polynomial or polynomial having degree as 2. So what is meant by a quadratic polynomial? It is a polynomial having degree as 2. So let us take an example for this. 5x square plus 3x plus 2. Make sure that polynomial is nothing but it doesn't have is equal to 0. When we keep is equal to 0, then it becomes quadratic equation. So this is a polynomial and has the degree of the polynomial as 2, in which it is called as the quadratic polynomial. Let's go to the next topic called as the quadratic equation. So what is meant by the quadratic equation? Let us discuss about its definition. So quadratic equation is nothing but it is in the form of ax square plus bx plus c is equal to 0, where a, b, c are real numbers. So quadratic equation is nothing but it is in the form of ax square plus bx plus c is equal to 0, in which a, b, c are real numbers. So let us take an example for this quadratic equation, which is 5x square plus 3x plus 2 is equal to 0. So a is equal to 5x square, 5x square, b is equal to 3, in which it becomes 3x plus c is equal to 2, which is equal to 0. This is equal to 0 makes this quadratic polynomial as a quadratic equation. Hope you understood about this quadratic equation and also the difference between the quadratic polynomial and the quadratic equation. Let's go to the next topic, that is solution or root or 0 of the equation. So solution is nothing but a value which satisfies the equation. So the term satisfies here in this definition means that LHS should be equal to RHS. So let me repeat the definition. That is, solution is nothing but a value of x which satisfies the equation. So that is called as the solution. So satisfies here means LHS should be equal to RHS in any quadratic equation. Let us take the example of this solution. So let us take the quadratic equation. As we have learned, it is in the form of ax square plus bx plus c is equal to 0. Let us take the example as 5x square plus 3x plus, okay, let me take it as 2, which is equal to 0. So let me take this x as 0. We have to get LHS is equal to RHS. As we have learned, the definition of the solution in it is the value of x which satisfies the equation. Here satisfies means LHS is equal to RHS. So to make LHS is equal to RHS, we have to substitute the value of x. So 5 into 0 square is 0 plus 3 into 0 plus 2 is equal to 0. 5 into 0 is equal to 0 plus 0 plus 2, which is equal to 0. So here 2 is not equal to 0. So 0 is not the solution of this quadratic equation. So this is how we find the solutions of a quadratic equation. The possible, let me write it, the possible solution of a quadratic equation is alpha. So we know the form of quadratic equation, which is ax square plus bx plus c is equal to 0. As the before topic, we have learned that x is the solution. That means alpha is the possible solution for any quadratic equation. So here that means that x is equal to alpha. So we have to substitute alpha in the place of x here. So a alpha plus a alpha square plus b alpha plus c is equal to 0. This will be the quadratic equation found. Hope you understood the topic. Let us move on to the next topic. The next topic is monic quadratic equations. Let me write it. That is monic quadratic equations. So here mono means 1. So what is the definition of monoquadratic equation? The definition is, in a quadratic equation, the second degree term coefficient has to be 1. So here monoid quadratic equation is nothing but, in a quadratic equation, the second degree term coefficient. So second degree term's coefficient has to be 1. That is why it is named as monoic, in which mono is called as 1. The example of this monoic quadratic equation. So a quadratic equation be in the form of ax square plus bx plus c. So monoic quadratic equation be like 5x square. No. It is 1. Actually, x square plus 5x plus c. here second degree term means this, and the first degree term is 5x. Here it is an equation, so that we have to keep is equal to 0. So in this monoid quadratic equation, this acts as the second degree term and this acts as the first degree term, and this is the constant term. We can take it as 2, 0, etc. It's any constant term, and as it is an equation, we have to keep it as is equal to 0. So hope you understood this monoid quadratic equation. Let us go to the next topic, non-monic quadratic equation. So what is this non-monic quadratic equation? As we have learned about monoid quadratic equation, which has second degree term as 1. I mean the second degree coefficient is 1. So here non-monic, mono means 1. Non-monic means what? As you have guessed, it is greater than 1. So non-monic means it is greater than 1. Any value can take it as. It may be 2, 3, 4, infinity. So non-monic means greater than 1. And it is also a quadratic equation. So let us discuss about the definition of this. So it is a quadratic equation. It is a quadratic equation in which second degree term, coefficient term, is not 1 but greater than 1. Okay. So this is the definition of non-monoid quadratic equation. So it is a quadratic equation in which second degree coefficient term. Coefficient is a very important word in this definition. So you have to remember that coefficient word. So coefficient term is not 1 but greater than 1. So that is called as non-monoid quadratic equation because it is greater than 1, which is called as non-mono. So let us go to the example of this non-monoid quadratic equation, which is quadratic equation form x square plus bx plus c is equal to 0. This formula takes an important role in this chapter. So let us take this. Okay, see here, this is the second second degree coefficient term. So the a has to be greater than 1. In the before one, it is x, in which the coefficient is 1. So here, it has to be greater than 1, in which we can take it as 2. So 2x square plus, we can take b as 3x plus coefficient as 5. Yeah, 5 is equal to 0. So this becomes a quadratic equation. It becomes a equation by keeping is equal to 0. So here the degree of the second degree coefficient is 2, which is greater than 1, which proves that this equation is a non-monoid quadratic equation. Let us go to the next topic, which is called as the pure quadratic equation. So pure quadratic equation. Pure quadratic equation is what? What is that? What is the definition of that? Means the definition of this pure quadratic equation is nothing but in a quadratic equation, In a quadratic equation, the first degree term will be missing, or there will be no first degree term. So pure quadratic equation is nothing but, in a quadratic equation, the first degree term will be missing, or there will be no first degree term. So by this we understand that the quadratic equation, there is no first degree term. Simple way. So let us take an example for this. So as you know, quadratic equation, in any question about this quadratic equation, we have to mention a formula, that is ax square plus bx plus c is equal to 0. That is mandatory. By writing this formula, you may get few more marks because you have a great explanation by this formula. So here, the first degree term, I have told you that monoquadratic equation or any quadratic equation, this is the second degree term. This is the first degree term. As pure quadratic equation has first degree term missing. So here this bx will be missing. So let us take an example like 3t square plus, let be the constant be 2 is equal to 0. So here the first degree term has been missing, in which this quadratic equation is called as a pure quadratic equation. So it becomes an equation by is equal to 0. Make sure that not only this quadratic equation but any equation has to be has e is equal to 0. When we keep is equal to 0, then it becomes an equation. Let us go to the next topic. This topic we had heard in many grades. So that the topic is algebraic identities. As this algebraic identities make a important role in all the chapters, it makes an important role in this chapter. So algebraic identities, that you have to remember these identities to solve any problem in this chapter. So let me discuss about algebraic identities. So the first identity is a plus b whole square. As you all know, it is a square plus b square plus 2ab. So the second identity is a minus b whole square, which is equal to a square minus 2ab plus b square. You have to remember that a minus b whole square is equal to a square minus 2ab, and it has plus b square. So next identity is a plus b into a minus b, which is equal to a square minus b square. So the fourth identity is a plus b whole cube, which is equal to a cube plus b cube plus 3ab into a plus b. The fifth identity is quite opposite to the fourth identity, which is a minus b whole cube, which is equal to a cube minus b cube minus 3ab into a minus b. So these are the 5 important identities which are being used in this chapter. So you have to learn all these identities to make your questions simpler and get or score more marks. So the first identity, let me revise all these algebraic identities. Which the first identity is a plus b whole square, which is equal to a square plus b square plus 2ab, and a minus b whole square, which is a square minus 2ab plus b square. And a plus b into a minus b is equal to a square minus b square, and a plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b, and a minus b whole cube is equal to a cube minus b cube minus 3ab into a minus b. Hope you understood all these topics in this quadratic equation chapter. I will meet you in the next episode. Bye bye.